Just quickly, some siting issues that you need to think about when you're looking at your property and you're thinking, will wind work for me? The top right picture is basically trying to show how wind flows over things. So as it moves over your home and over trees, it falls off the other side and creates turbulent air, which basically would spin a turbine in all different directions and is not what we call clean wind. You need that turbine to be elevated up. The general rule in the industry is about 20 to 30 feet above everything within 300 feet is sort of the ideal. Um, Oftentimes you can't get that, but the general rule is you want to get it up into that clean wind. The image on the left basically shows if you had the same wind turbine, the same capacity to make electricity, and you put it at different heights, you get a tremendous amount of range in the power output. So if you go from, the first is at 33 feet, if you went up to a 60-foot tower, you would increase its power by 41%. And so that's the same head, is just going up higher. And the reason for that is because the higher you go, the faster the wind is, and the power is basically the cubed of your wind velocity. So the higher you go, the more power you're going to get. So how can you use this power that you create? This is a discussion we could have that will go on for a long time. But there are kind of three different ways as I see it. One is that you can store it in batteries. Okay, and this can be used, you can use an inverter and pull it out for later use, or it can be in a backup situation. If the grid goes down, then you'd have reserves to run your home off of. The other way that you can do it is you can basically use it to reduce your own electricity bill. And that's what we call net metering. But if you produce 100 units from your wind turbine and you consume 1,000, then you'd use net metering to knock it back to 900. The other way that you can do it is you can sell it back to the grid. So we have these advanced feed-in tariffs, like Rob was mentioning. Unfortunately for wind, it's not as attractive as solar. Solar, you have a great rate of 42 cents. We at Renewable Energy of Plum Hollow, we sell all of these things, and by all means, I agree with all the previous speakers that solar thermal is the best investment, then PV, and then wind. So how much power can you actually get from a turbine? This is all very confusing, and I'd say this is probably the #1 question I get in the store. You see a turbine that says, you know, it's a 1.4 kilowatts or a 3.7 or what have you. What does that mean? And it's very confusing because there's no real standardization to this. And what you need to look at is the actual power output of a turbine. So every turbine that you look at will have a product sheet that will look something like this. And this graph basically shows you wind speed and it shows you the power output. So the faster the wind, the more power you'll get out. Now, what it's rated at on the right-hand side is your rated capacity of 2.4. Well, if you find where 2.4 is, it's over in here at these speeds. And so that's what's called the rated wind speed. So this is the 29 miles per hour over here. So that's a very fast wind. And you're not going to get that on average on a typical day in Kingston. So when you buy this turbine, if you're expecting to get 2.4 kilowatts out of it, well, you'll be mistaken and disappointed likely. The other critical one to look at is the cut-in wind speed. So this is when the turbine will start producing power. So they're designed for all different types of scenarios, and this one has quite a low wind cut-in speed. And then the last one is the survival wind speed. So this gives you an indication of, in a hurricane, how will it do. So okay, so you say, fine, that's how much it's going to make, but what is it going to make in my place? Well, this is the second graph that you'll almost always see in a product specification sheet. So you go to somewhere like the Canadian Wind Atlas, and it says, okay, well, at your property, you're going to have, on average, 10-mile-an-hour winds. So you go up here, and it says, I'm going to make 230 kilowatt hours a month of wind. That's what you can expect, not 2.4 kilowatts 24 hours a day or some other kind of calculation like that. You have to look at a monthly average or an annual average. So what are the costs and what are the paybacks? Like I alluded to earlier, the paybacks aren't as strong as the other ones. Um, the systems like the one you're seeing there would cost quite a bit. This is a case study of a 2.4 kilowatt generator that we installed at our store, and all of you can come see it in action. It's hooked up and it's selling back to the grid. Um, and the cost of that system is about $16,500. Now the pie chart represents how that's broken out. So obviously the biggest chunk, 2/3, is equipment, and you got about a quarter labor, and then miscellaneous fills in the rest. So what does that mean? Well, what would that wind turbine do for you at your home? The average person, or the average home in Ontario, uses about 1,000 kilowatt hours a month in electricity. Now this is the average home. This is a 3-bedroom home. This isn't anybody thinking about conservation. So it's easily said that people who are on the track and who are here tonight would use significantly less than that. But even as the average, a wind turbine like this would generate about 400 kilowatt hours a month. That's about 44% of this average. So if you use significantly less, that could be 2/3, 3/4, or it could be less than that too, depending on how you run your home. So what does that equate to in electricity? Well, unfortunately, this turbine gets 11 cents per kilowatt hour to feed back in. Well, that's the same amount that you get charged basically when the power comes to you in your home. So you pay 5 or 6 cents, and then you have the delivery charge and the famous debt retirement charge. By the time it gets to your outlet, it's about 10 to 12 cents. So they're going to pay you the same price that you're going to sell to them. So oftentimes it doesn't make sense to put in an extra meter like Rob did to meter how much electricity you're going to make, because that's an additional cost.